Okay, year 12. So next type of thing then. This is going to combine our work on algebraic division and our work on partial fractions. And that's going to enable us to deal with improper fractions. Quick reminder, this fraction is improper because the degree of the top is 2 because of the x squared. The degree of the bottom will also be 2 because of x squared. And that makes it improper. So given that this here equals this, find the value of a, b and c. Now this example is on page 17 of your textbook. I personally think the way they do it in the textbook is sort of longer than it needs to be and quite fluffy and awkward. And so it's not going to be the way I'm going to show you here. I think this way is slightly more straightforward with slightly less steps. But you're very welcome to look back in the textbook in case it's helpful to you. So first of all, I'm just going to rewrite the original identity from, oh, I need to switch into my pen. Switch into my pen, I'm just going to write out the original identity from the question. A plus b over x minus 1. Okay, so I've just written very badly the original identity out. And so all we're going to do now is we're going to multiply both sides by x minus 1, x minus 2. So I'm multiplying both sides by the denominator of my fraction. So the left-hand side is just going to become 3x squared minus 3x minus 2. And then the right-hand side, well, it's going to become x minus 1, x minus 2 lots of a. Then in terms of b, if I multiply this whole fraction by x minus 1, x minus 2, I'm just left with x minus 2 lots of b. And then in terms of my final fraction, I'm going to get x minus 1 lots of c. Okay. If you're not sure on why that's happened, it may be worth going back over the work you did before half term on partial fractions. So now, to work out a, b and c, we can just do some substitutions. So I'm going to start off by substituting in, let's say x equals 1. So when I substitute in x equals 1, I get 3 minus 3 minus 2. I get minus 2 on the left-hand side. Then on the right-hand side, when x equals 1, well, this becomes 0, so I get 0 lots of a. This becomes 1 minus 2, which is minus 1b. And then this here, 1 minus 1 is 0, so 0c. So after that, if minus 2 equals minus b, it therefore follows that b equals 2. And now we're going to make a second substitution. So let's try substituting in now x equals 2. So when x equals 2, on the left-hand side, I'm going to get 3 lots of 2 squared, which is 12. 12 take away 6. 6 52 is 4. So I get 4 equals, then here, when x equals 2, well, this is going to become equal to 0, so I get 0 lots of a. Then I'm going to get 0 lots of b, and then I am going to get 1c. And because of that, c is equal to 4. And then I just need to make one more substitution. Now, the final substitution is not that important. I'm going to substitute in x equals 0, just because I think it's the most straightforward thing. So, if x equals 0, on the left-hand side, I'm going to get minus 2. Then on the right-hand side, well, minus 1 times minus 2 is positive 2, so 2a. Minus 1 minus 2 is minus 2b, sorry. And then here, minus 1c. So after that, we get minus 2 equals 2a. Then we know that minus 2b is going to be minus 4. We know that minus 1c is going to be minus 4. So we get minus 2 equals 2a minus 8. We can add 8 to both sides, giving 6 equals 2a. And therefore a equals 3. So finally, if we just wanted to write it back in the form in the question, it would be 3 plus b is 2, so 2 over x minus 1 plus, and then c is 4, so 4 over x minus 2. So that's the way I would suggest tackling that type of question there. Okay, so year 12, this question here then. So we need to express this thing in partial fractions. Just before we start that, remember that my numerator has got degree 2 because it's got an x squared in. My denominator will also have degree 2, okay? Because when we expand out, that will have an x squared in. So that's going to have really big implications for what we do next. So what we're going to do is we're first we're going to write out that, the original expression again, so 9x squared plus 20x minus 10 over x plus 2, 3x minus 1, like that. And that's going to give us a, and it's going to give us just a by itself. Because this is an improper fraction, we know there's going to be just a term by itself. So it's going to give us a plus b over x plus 2 plus c over 3x minus 1. So then what we're going to do is we're going to multiply both sides by our denominator. When we multiply both sides by our denominator, on the left-hand side I get 9x squared plus 20x minus 10 equals, then we get x plus 2, 3x minus 1 lots of a plus 3x minus 1 lots of b, and then we get x plus 2 lots of c. And so now we just need to make some substitutions to make our brackets equal to 0. So the first substitution I would make is x equals 2. No, I wouldn't. I would make the substitution x equals minus 2. So at x equals minus 2, then I am going to get 36 minus 49. On the left-hand side of my equation, I'll get minus 14. Then here, when x is minus 2, well, a is going to be equal to 0. Then here, when x equals minus 2, I get 3 times minus 2 is minus 6. Minus 6 minus 1 is minus 7. Minus 7b. And then when x is minus 2, this is 0. So after that, I've got this here, which therefore means b equals 2. Then I would make a second substitution. For my second substitution, we want this 3x minus 1 term to be equal to 0. So 3x minus 1 equals 0. Then it's true that x equals 1/3. So we're going to substitute in x equals 1/3. When I do that, I get, let's see, 9 lots of 1/3 squared is 1. That's 20 lots. On the left-hand side of my equation, I get minus 7/3. Then on the right-hand side of my equation, well, this a term will be equal to 0. This b term will be equal to 0. And then this c term, when x equals 1/3, is 7/3. So I get minus thirds equals 7/3 c. And so therefore, c equals minus 1. Then one more substitution to make, I would recommend we go for x equals 0. When x equals 0, on the left-hand side, I just get minus 10. Then on the right-hand side, I'm going to get minus 2a minus b plus 2c. So then I get minus 10 equals minus 2a minus 2 minus 2. So minus 10 equals minus 2a minus 4. So then if we add 4 to both sides, minus 6 equals 2a, and therefore a equals 3. So now we've done all of that. It's just good practice to rewrite exactly what we mean. So we've got a equals 3. So our final answer is 3 plus, then b is 2. So it's 2 over x plus 2, and then c is minus 1. So minus 1 over 3x minus 1. And that's that.